Okay, Year 10, I'm going to go through some of the questions that I've asked you to do from Mathscape exercise 10.8. I'm not going to start with some of the earlier ones. Most people got up to about 7, 8, 9 or 10. I'm going to start with question 13 and I'm going to do the prime numbers through till there. So if you have any trouble with these, leave space for the ones that you're having trouble with and move on. Don't just go and stop. Don't just stop at whatever one you get up to. So I wanted to do 13 because it doesn't have a diagram, and I think the key to them is drawing the diagram. And the ones after 13, they've all got a diagram, so it's just a matter of applying the rules that you've got. So let's have a look at 13. So it says I've got a triangle PQR. Now remember, whenever you draw a triangle and you're applying trigonometry, try to draw it so that it's not equilateral or isosceles. So I'm going to put P here because it's 60 degrees. And then R, and it's bigger, it's 75 degrees. And then I've got Q here. And Q is 8 centimetres. Now, I've got to find the exact length of QR. The exact length. So I'm going to call this, I'll call it P, little p, because that's the way we label our triangle. So straight away, I look at it, I'm going to do the sine rule, but it's asked for exact length. So this will be interesting because I'm going to have sine 75. Now I can't find sine 75 as an exact length. I'm looking at the answer and it does give me an exact length. Unless, of course, I work this out, 75, I'm going to find this angle, which is 180 minus 75 minus 65. I'll pull out my trusty calculator. 180 minus 75 minus 65, which gives me 40. So I've got 40. Yeah, I still don't. I know I can get. No. Well, let's see how this works out. So, P on sine 60 equals 8 on sine 75. Well, P equals 8 times sine 60 on sine 75. And I know sine 60 because I know my exact values. And this is 60. This is 1 and this is 2 and this is root 3. Remember, you get that on your formula sheet. So it's going to be 8 times root 3 on 2. But sine 75. Sine 75. I don't know how they expect me to do that. I can't use the sine 40. And I don't know how they expect me to do it. I think it's a typo because I'm looking at the answer. I'm looking at the answer and the answer is 4 root 6. And for it to be 4 root 6, this has to be 1 on root 2. And I know sine 45 is 4 on root 2. 1 on root 2. So that gives me 4 root 3 multiplied by the reciprocal root 2, which gives me 4 root 6. So I think that's a typo. I think that's a typo. I think that is meant to be 45, which will then make that 70. But that makes no difference. I'm pretty sure that's what it is, because the answer is 4 root 6. And there's no way that can be wrong. So I think this is a typo. It should be 45. And if you do that, you get the right answer. And I know that sine 75 does not equal sine 45. And I know that that's what's going to pop out. I'll just draw in here, and you should know this, 1 root 2, 45. And what happened here was that the 8 went into the 2 went into the 8 4 times, so I get 4 root 3 on top, and I'm dividing by a fraction, so I'm multiplied by the reciprocal, which is root 2 on 1, which gives me 4 root 6. Look, that's the answer. I may be wrong with 13, but I do not think that angle is 75. For the answer that they get in the back, I think it must be 45. All right, well, that was a bit of a difficult one to start with. Let's move on. And it's another exact value one. I'm going to 17. If I look at 17 here, they've given me the diagram. This one's a little bit easier. And what I've got is a equilateral triangle. And they've said, show that the area equals root 3 on 4 s squared. Well, luckily for me, I understand the properties of an equilateral triangle, and I know that's 60. So I can just quickly use the area formula. And area equals a half AB sine C. And A and B are the same. It's S times S sine 60. Well, that gives me S squared on 2. And sine 60, if I look back up here, sine 60 is root 3 on 2. So root 3 on 2. And that gives me root 3 s squared, and 2 times 2 is 4. And that is question 17. That's pretty easy. Let's move along here. 19. Okay, this is a bearings question. A bushwalker walks 8 kilometres due east, and they've got the diagram here for me, so that's okay, from L to M, and then walks 13 kilometres on a bearing of 26, and they've indicated it in there, and they've put the 90 degrees in for me, which is fantastic. So I know that middle angle is 90 plus 26, so I might just work that out. 90 plus 26 is 116 degrees. So that angle in there is 116 degrees. Okay, calculate the distance from L. Calculate his distance from L. So I want here, I'm going to use X to represent that. And I'll start here. So here's 18. And I'm going to use cos. And we're going to use cos, yep. So x squared equals 13 squared plus 8 squared minus 2 times 13 times 8 times cos 116. And I'll do that on my calculator. So 13 squared plus 8 squared minus 2 times 13 times 8 times cos 116. So 324, I think. 324.18 ... Don't forget to square root that. To get your final answer. So square root your answer. Hey, Vans. No, not really. And it's 18.00. So it says to the nearest kilometre, so we'll go 18 kilometres. And I'll look over at the answers, and it's 18 kilometres. Now the second part of the question, so that's part A. 18, this is question 19. It says, find the bearing find his bearing from L. So we've got to find, I'm just going to zoom in here, from L. So you're standing at L, so we've got to find that angle in there, which means essentially we find this angle in here, we'll call that alpha. If we find alpha, we just subtract it from 90, which will give us the bearing. So I'm going to use sine rule. I'm going to use sine rule here. And I'm going to use their measurements. So, oh no, I'm going to have to use ours because I don't have that other angle. I could use the cos rule here, but I think the sine rule is just simpler. I could use the cos rule because I've now got this 18. And I could use the cos rule to find that angle, but I'm not going to. I'm going to use sine. So here's B. And what am I finding? Sine alpha over 13 equals sine 116 over 18. Now that's a rounded answer. Remember, 18 kilometres from over here. We've rounded that. So we'll see what we get. So sine alpha equals 13 sine 116 over 18. And I inverse sine all that. To get my final answer. So let's get the calculator up. So shift sine 13, oops, I better do a fraction. 13 times sine 116 over 18. And close those brackets. 40 degrees. And they want it to the nearest degree. So 40 degrees. And I'm looking at 10.8, question 19. They've got 50 degrees. Bearing. So therefore the bearing, remember that's what we're finding, is 90 minus alpha, which is 90 minus 40, which equals, now remember you've got to have 3 digits, 0, 5, 0 degrees. You can put the T for true because it's a true bearing. Okay. Now you could have used the cos rule. Hopefully you would have got the same answer. It may have been a little bit different in its decimal allocation. So let's move along. The next prime number is question number 23. So here I'll have a look at 23. Now with 23, I've got x, y, z. And z is a point such that it bisects use a sine rule to find the size of x, z, y. So I'll just zoom in a bit here. X, Z, Y, I'm going to call that theta. And I know that this distance is 21 because it bisects it, and that distance is 21. So I can do the sine rule pretty easily here. I write what I'm finding first. Sine theta on 30 equals sine 35 on 21. I'm just going to do this all in one go. I'm going to multiply the 30 and I'm going to inverse sine the whole lot. 30 sine 35 on 21. And I'll go to my calculator, and I've got all that in there, so I'm just going to go back along and change the numbers. So you've got 30 35, and come down here, 21. Now at 55 degrees, what do they want it to? Nearest degrees. 55 degrees. When I look in the answer and I look to 23, and they get 125. And now I need to think to myself, oh, Mr. Tonkin, look, it's obviously obtuse. It looks like a duck. It walks like a duck. So it's probably a duck. But it is obtuse. So x, z, y equals 180 minus 55, which is 125 degrees, which is the correct answer. All right. That's A. That was a little tricky. I didn't state it, but I needed to be aware that that's what it looked like. Hence, find the size of W, X, Z. Well, if that's 125, that means this angle must be 55 because it's a straight line. And now I can find this angle using sine again. So part B, let's have a look at it again. Sine alpha, and I'm looking at this, it's acute, over 21 equals sine 55 over 18. Again, I'm going to do it all in one go. So alpha equals inverse sine, multiply the 21 across, 21 sine 55 over 18. Go to your calculator. It's all still in there, so we'll just go backwards. And what about 21? Uh, 55 and 18. And I get 72.8 degrees. It wants it to the nearest degree. So 73 degrees, which is correct. All right, so hopefully that's given you a bit of an insight. Remember, I think question 13 is incorrect. I think they really wanted 45, not 75. If anyone else is able to work it out using 75, I'll be very keen to hear from you. Anyway, good luck. I hope you enjoy doing your trigonometry, and I'll see you next lesson.